Welcome back. Let's go ahead and take a look at the notes for 6.2 or 6-2, traversing through arrays. So this is actually extremely similar to what we do with strings. If you recognize or remember what we used to do, we would take a for loop, we'd start at index 0, and we'd go all the way to the string's length minus 1. As we kind of talked about last time, that's going to be the same exact scenario when we run through these arrays. We will go to the length minus 1 because that is the last index. The only thing that I do like to mention over and over again is the difference between these two things right here. You'll notice that up here, your string can change length, so it is something that has to be, is a method that is being called that has to calculate how long it is, whereas a instance variable of length is created once you instantiate an array. And it's kind of a constant value. Once you set it, it cannot be changed. You cannot change the size of the array at all. So one of them is accessing, the way I think about it is one of them is accessing a method, where the other is accessing some sort of a variable that it has. It's a good way of remembering that. The basic for loops are going to be similar to what we see with those strings again. So here you'll notice that we use an initializer list to create our array right here. Technically, does this happen on 2 lines? Yes. But the way that your computer really thinks about this is, anyways, it squishes all these letters together. It really thinks of all of this as one single line of code because it doesn't run into its final semicolon until right there. So although the string starts up at the top, the end of that semicolon is kind of the definitive end of that line. We could have expanded this over vertically as many lines as we wanted. But we make it an array of the days of the week, holding their abbreviations. Our for loop will start at 0. We will go all the way until the length of that array. Note there are no parentheses again. And then we use the power of that variable I to access the different data points inside that array. So since it starts at 0 and the first index of our array is 0, this line of code that I've just highlighted will access the index 0 and print it out. The second iteration after we update that I variable, we would be grabbing onto index number 1, and then following that index 2, 3, so on until we find the length of this array. So eventually what this would print out is it would print out each of these days that you see in the list, one after the other, and it looks like it puts a space in between each of them. There will be an additional space at the end after the word Saturday, but it probably won't be visible to the user. You can also use for loops to fill arrays. I think that's one thing that we haven't talked about too much yet is, hey, you can create this array full of integers. They all start at 0. How can I actually assign them values after I've built an array? We can use the initializer list, but sometimes that's not always the scenario that is possible during our programming. And so instead what we often do is we'll build the array, it starts empty, and then we will fill it. And to fill elements of the array, all we're looking to do is really kind of assign those values something to be new. So again, I look at this equal sign as a left and right side. The left side is what you are changing. I'm going to my array and I'm grabbing one of the indices that are in there. I'm going to change that indice. Index, singular. What are you going to change it to? The right side is just a pure calculation for math. Whatever this value is, that's what I'm going to overwrite that index with. And so when we look at the process that we're building here, on this line, it looks like we're building an array of 10 integers. Reminder, all values are zeros at this point in time. Those are the default values that those take on. We start our I value at 0. We go to the length, again, no parentheses, up by 1 every single time. Let's go ahead and grab index 0. Let's fill it with the value of, check this out. 0 times 3 would have given us 0. You will notice the first value of our array here is actually 3 times 1. Since our I value starts at 0, we do have to perform a small calculation to get that value there. The other thing that you might notice here that's important are those parentheses. If you did not have those parentheses, remember PEMDAS would have tried to do this first. So we have to force that I plus 1 to give us the value of 0 plus 1 for the first iteration, and then so on and so forth. You will then notice that the last iteration of this one would be 9 plus 1, so the last iteration would be 10 times 3, would give you a 30 out of that. But again, we go ahead and assign that value to be something, and then immediately after that, it looks like we print off that exact value. So we're using the I value to fill it, and we're using that I value to print it, all within the same exact for loop. So this would print, if you really wanted to look at it, they're all in the same line. It looks like multiples of 3 10 times. So we got 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. And again, the indices for these would be 0, 1, 2, all the way up to the length minus 1. Passing these values as parameters into a method These, again, we just have to follow that general rule we learned last time, that when you pass in primitive data types, it makes copies of them, and therefore the changes made in that method to the copy don't actually happen to the real one. And then when we pass in objects, everything works the way that we want them to. If we make changes to that object in that method, it will occur to the actual object outside of it. And the reason for that, again, is the whole balloon idea, where we have our, if we're going to build some sort of a dog class, if I build a dog and I kind of think of that balloon that's tied to it, and I say, hey, I'm going to name this dog Ralph as a variable. So a line like this would look something like dog Ralph equals new dog. This is exactly what this would kind of create here. And then if I passed into a parameter, let's say I had a method header, again, that looked like this, public void bark, and it said, I need some sort of a dog from you, and we'll just say dog A. What ends up happening here is this string again says, hey, instead of making a new object, I'm really just making a new variable, a new reference variable that can refer to the same exact dog object that we have. So therefore, any changes that are made to that dog A inside of this method are indeed affecting the same object that Ralph is pointing to. So if I wanted to go ahead and call this bark method, let's just say it's static for this instance, and I pass through Ralph, any changes made to Ralph or any changes made to A are also affecting Ralph at that point in time. So that's the way that I still remember that, is primitive data types don't do what you want them to. Objects, and basically anything besides primitive data types, do exactly what you would like them to. And then if we took a look at this code here, just a short little analyzation, these first few lines that we're looking at here, we're just kind of using this thing called multiple arrays of 3. And this is going to go ahead and print these values out, all the multiples of 3. We're assuming that we have the lines of code that we had written up here to kind of fill that. And from there, we go ahead and pass this through into a method. This method is called multiples of 3. I'm sorry, the method itself is called change by number. So we call this, it says, hey, you're going to give me some sort of an integer array. Take note of this. I think this is important to see. The data type that we are receiving into this is an array of integers. So you will see those hard brackets there. And then the second thing I'm grabbing is some sort of a number, what I'm increasing them by. So I am utilizing a for loop right here. Starts at 0, goes to the length, up by 1. I'm accessing the ith element of that array because that I value is going from 0 to 9. Each one of those elements, and this is again, left side. I'm changing the left side. So I'm actually accessing every element and deciding what I want it to be. What am I changing it to? It says I'd like to add on number to whatever value that is, and then store it back as itself. Looks like this method is going to take an array, an integer, and add that integer to every single value that we have. So if we look at the array that we actually had started with, they were values of 3, 6, 9, 12, all the way up to 30. Once I threw this method in there, I said, can I please change every single one of these by 1? Sure, we now have every single value that is 1 larger than the original array. And again, the reason that these changes take place is because when we pass in these values right here, we are actually creating another string tied to that balloon. I guess I should have done this example the first time. I think we have this thing called, we have this variable that we have called multiples of 3, I believe is the name of the array. Yes, it is. So this multiples of 3 is tied to this array that we have right here. I'm just going to fill this in. And then all of a sudden we pass it in to this original array. So once again, this original array is another variable that we reference to this object. And so it is tied to the same balloon. Any objects change, or any changes made to the object in the original array, it will be made to multiples of 3 as well. And I believe that is it for the day. Have fun.